Greetings to you all. This is Rakshita Joshi from Department of Chemistry, Doon University, Dehradun. It is a privilege to speak today on a subject that is both ancient and timeless, which is Indian knowledge system. In this presentation, we specifically focus on the war strategies by Kautilya, in which the topic we are going to discuss are introduction and science behind some of the statements of Kautilya Arthashastra. The kautilya arthashastra involves the political strategies, war strategies, and spycraft, and etc. So let's begin with introduction. Somewhere or other, we all have heard about Kautilya or Acharya Chanakya, who is also known as Vishnugupta. He was philosopher, economist, and teacher who wrote the Indian political strategies and treatises, the Arthashastra. Kautilya was the one who played an important role in establishment of Maurya dynasty. In this presentation, there will be broad discussion about the statement of Kautilya's Arthashastra and science behind its statements. And the statement we are going to discuss are taken from chapter number 4, the operation of a siege, from book 13, the strategic means to capture a fortress, and chapter 2, wonderful and delusive contrivances, from book 14, secret means. And yes, the statements from the above books and chapters are pointed below are only some of the statements, and also their sequence is also not specified. And let's begin with these principles. From book 13, chapter 4. The powder of all the metal as red as fire, or the mixture of powder of kumbhi, shisha, trapu mixed with the charcoal powder of flower of paribhadraka, palsa and hair, and with oil, wax and turpentine is also an inflammable powder. It is the exact statement which is taken from the Kautilya Arthashastra. Let's break down the above text. The powder of all the metals as red as fire. It refers to the powder of metal that can burn or support the combustion. And science behind this is finely powdered metal like aluminium, magnesium, iron or zinc can be highly flammable because of their highly increased surface area, due to which these metal reacts with oxygen rapidly and the process called combustion. And some of the metal powders show pyrophoricity, means they ignite spontaneously or burn intensely when exposed to flame or friction. Some examples of pyrophoric metal powders are aluminium powder, tungsten, magnesium, platinum powder, and titanium powder, zirconium powder, etc. The red as fire likely refers to the reddish glow or intense heat produced during the combustion. And here is a screenshot of text which is taken from a research article which is mentioned below with reference. This text tells about the pyrophoricity, which is a capability of igniting spontaneously in air. Daham states metal powder are considered pyrophoric if they react and ignite in presence of air at normal ambient temperature, and normally finely divided powder which do not have protective oxide film ignite pyrophorically when a critical specific surface area is exceeds. He further states the heat of formation of oxide layer when exposed to oxygen in air has a direct control on whether the metal powder is pyrophoric. Now let's see the other component mixture. First is powder of kumbhi. Kumbhi is Gemellia arborea, which is a tree. Sisha, which is lead, trapu, zinc, and charcoal powder from Paribhadraka, which is Deodar, Cedrus deodara, its botanical name. Palasa, which has botanical name Butea frondosa, and human hair or animal hair. The Gemellia arborea is a tree which shows the flammable properties when ignited, and with oil, wax, and turpentine. Now we will talk about metal. Mm, The metal mentioned were lead and zinc. These metals themselves are not highly flammable, but when in powdered form and heated, zinc can burn with bright bluish green flame. And carbon source are charcoal from specific plant and hair, which act as fuel. Hair contains keratin, which is rich in nitrogen and sulfur content, which enhances flammability. Now let's talk about oil, wax and turpentine. All three are combustible organic substances. Oil and wax provide long-lasting burn. Turpentine, a resin-based volatile oil, is highly flammable and ignites easily. This combination is similar to napalm-like mixture. So above mentioned combination mixture is potentially flammable on the basis of properties of ingredients. Now let's see another statement from book 14 chapter number 2, which is when the oil extracted from the fruit of kusha, which is ficus religiosa, and amra is poured over the fire, it burns even in stone. This is also the exact statement which is taken from kautilya arthashastra. But according to botanical nomenclature, kusha and ficus religiosa are not same, so they both will be discussed separately in this presentation. So firstly, kusha grass, which has botanical name Desmostachia bipinata. The combustion and fuel properties of Desmostachia bipinata has not been studied widely, and there is very limited fuel research on kusha grass. But its cellulose-rich structure gives its combustibility suitable for low-intensity fires. It shows high flammability when dried with moderate calorific value. It gives low ash content with fast combustion. Now let's talk about people, which is Ficus religiosa. It contains compounds like tannins, alkaloids, and resins, and it can be flammable in small quantities, but it is not viable fuel. There is very limited study on the fuel and combustion properties of Ficus religiosa also. Now let's talk about amra, which is mango, having the botanical name Mangifera indica. Oil extracted from mango kernels, which is called mango seed oil or mango butter, are combustibles. Many research articles shows that mango seed oil are suitable for production of biodiesel, and uh, the reference for these statements are mentioned below the text. Now, the properties of above ingredient do not satisfy the literal statement, but the processed extracted oil from mango seeds act as fuel to the fire, and kusha grass Desmostachia bipinata shows combustibility. So, according to these properties of ingredients, above statement is partially true. Now, let's see the third statement or last statement. Sea foam wetted with oil and ignited keeps burning when floating on water. So, the oil is flammable and floats on water. The science behind this is the oil soaked foam act as fuel reservoir. Since oil is hydrophobic and less dense than water, it stays on the surface where it can be ignited and continue to burn. Oil typically has a density between 0.8 to 0.95 gram per centimeter cube, whereas water is about 1 gram per centimeter cube. Water is polar and oil is non-polar in nature due to polarity difference. The foam structure traps fuel and air. How? Let's study this. The foam is porous, traps both oil and air, which promotes sustained combustion. The structure keeps the oil in place and provides insulation, reducing heat loss to surrounding water. A study on combustion and flame spread over fuel-soaked porous solids notes that the combustion properties maintained in porous beads due to structural characteristics. The flame spread rate initially is rapid but slows as the fuel supply diminishes, indicating how porosity controls the combustion dynamics. And the reference for the above statement which I have made is mentioned below, which is from a research article also. Uh, Now, insulating effect of foam. Sea foam can act as thermal buffer. It prevents the water below from extinguishing the flame too quickly. This allows combustion to continue despite being on water. Now here is a picture which is a real life incident where it is truly looked like the ocean caught fire. In July 2021, a mesmerizing yet alarming blaze broke out on the surface of Gulf of Mexico. This incident happened due to the rupture of gas pipeline undersea in the Mexico. This incident resembles the above phenomena. So we can say that above statement is true. So, as a conclusion, we can say beyond the technical achievements, the integration of chemical knowledge with a holistic philosophy, emphasizing both intellectual pursuit and practical application for human well being, is a unique strength of Indian knowledge tradition. Now, I would like to sincerely thank all the audience who is listening to me for their time and their attention. Thank you.